Hi guys, today I want to talk about how to write equations of lines that are parallel and perpendicular. Now, I have some examples that I want to work with you. The first thing that we need to establish is that parallel lines have the exact same slope. So if you wanted to know if two lines are parallel, one way to figure that out is to find the slopes of both lines. And if they have the same slope, their slopes are congruent, then those two lines are parallel. Now, when we talk about perpendicular lines have slopes that have a relationship, and that relationship is that the slopes are the negative reciprocal of each other. And what I mean by that is if line A has a slope of 1/2, then a line that's perpendicular to line A will have a slope that is -2, because the reciprocal of 1/2 is 2. And we change the sign on that. So let me show you an example. Now, example 1 says are AB and CD, and that is segment AB and segment CD parallel, perpendicular, or neither. So let's find the slope of segment AB. Remember, our slope formula is y2 minus y1 divided by x2 minus x1. So the first thing we want to do is label points A as x1, y1, and point B as x2, y2. And now we're trying to find the slope of segment AB. And that's going to be y2, which is 2, minus y1, which is 5, divided by x2, which is 4, minus x1, which is 6. So 2 minus 5 is -3, and 4 minus 6 is -2. Now the negatives will cancel each other out, so I'm just left with 3/2. Now we need to find the slope of segment CD. And how do we find the slope of segment CD? Well, first we label point C, x1, y1, and point D, x2, y2. Now we plug that into our formula. C2, which is 0, y2, which is 0, minus y1, which is 3, divided by x2, which is -3, minus x1, which is -1. And so 0 minus 3 is -3. Here, these two negatives will come together to give me a positive. So this is -3 plus 1, which is -2. Once again, the negatives will cancel each other out, and I'm left with 3/2. So notice the slope of AB is 3/2, and the slope of CD is also 3/2. So what can we conclude? Are these two lines parallel? Are they perpendicular? Or neither parallel nor perpendicular? Well, since the slopes are exactly the same, we say that AB, segment AB, and segment CD are parallel. And how do we know they are parallel? Because their slopes are congruent. Now let's look at example 2. Find the slope, only the slope, of a line parallel to this line, y equals 3x minus 4. Now notice that this is in the slope-intercept form. Okay, my slope here is 3. My slope is 3. So find the slope of a line that's parallel to this line. Now any line that's parallel to this line will also have a slope of 3. Okay, parallel lines have the exact same slope. So if this line has a slope of 3, a line that's parallel to this line will also have a slope of 3. Now let's take a look at example 3. It says find the slope of a line that's perpendicular to the line 2x plus 3y equals 8. Notice that this equation is in standard form. And when I say standard form, I mean the form ax plus by equals c. Now first we want to transform this into the slope-intercept form. So we need to get this equation in the slope-intercept form. So the first thing we want to do is to remove the x term. And so we subtract 2x from both sides. 2x minus 2x is 0, so I'm left with a positive 3y equals negative 2x plus 8. Now, in order to get rid of this 3, my 3 is multiplying my y, so to get rid of that 3, I need to divide by 3. Okay? So now I'm left with y equals negative 2/3 x plus 8/3. Now, what is my slope? My slope is right here, m. Not mx, m. This is my slope, m. So my slope is negative 2/3. That's the slope of that line. Now a line that is perpendicular, a line that's perpendicular to this line is going to have a slope that is the negative reciprocal. That means my new slope will be the negative reciprocal of my old slope. Okay? Reciprocal meaning I flip the 2/3, so it becomes 3/2, and my sign changes from a negative to a positive, so my new slope is going to be a positive 3/2. So lines that are perpendicular to each other have slopes that are the negative reciprocal of each other. So notice the slope here was positive and the slope here is negative. This slope here is 2/3 and the slope here gets flipped and becomes 3/2. And that's what it means to be the negative reciprocal of each other. Now you will pause the video and you will try these A and B on your own. It says find the slope of a line parallel to the line 2y equals 8x minus 12. So you'll pause this and go ahead and do it, and I'll come back to you with the answer. Okay, so our slope here is 4, and a line that's parallel has the exact same slope. So the slope of a line that's parallel to this line, 2y equals 8x minus 12, is equal to 4. Okay, so for the now try these B, it says find the slope of a line that is perpendicular. So you know you're going to flip the slope and change the sign of this equation. So we transform this equation into slope-intercept form. We found out that the slope is a negative 3/5. So my new slope of a line that's perpendicular, and I use the sign for perpendicular, okay, will be m equals, so we flip that 3/5 to become 5/3, and we change that negative to positive. So this is my new slope. Now for example 4, it says write the equation of the line that passes through this point 6, 1, and is parallel to the line y equals negative 2x minus 6. Now because it's parallel, the new equation will also have a slope of negative 2. So let's use the point slope formula. This is our point slope formula. Okay, and our point is x1, y1, which is 6, 1. So here we need to plug in our x1 or y1 and our slope. Now we know that our slope is negative 2 because it's parallel, and parallel lines have the exact same slope. So y minus y1, which is y1 is 1. And that is equal to m, the slope is also negative 2, x minus x1, which is 6. Okay, and so if you distribute this negative 2, this becomes negative 2x, and negative 2 times a negative 6 is going to give us a positive 12, and over here we have y minus 1. Now what we are trying to do is to get this into the slope-intercept form. So I add 1 over here, and I add 1 over here. So y is equal to negative 2x plus 13. So this is the equation of a line that passes through the point 6, 1 and is parallel to the line y equals negative 2x minus 6. Finally, we will write the equation of the line that passes through the point 3, negative 2 and is perpendicular to the line y equals 3x plus 2. Perpendicular means the slope is going to flip. So you're going to flip the slope and you're going to change the sign, which means if it's negative, it becomes positive. If it's positive, it becomes negative. So my slope here is 3, which can be written as a fraction 3 over 1. Now, the slope of my line that's perpendicular to this one is going to have a slope. My new slope is going to be the flip. So I flip this, it becomes 1/3, and I change the sign from positive to negative. So now all I have to do is plug that information into my point slope formula. Point slope formula. I'm plugging in my point, x1, y1, and my slope, which is m. So this becomes y minus y1. My y1, over here I have x1, y1. My y1 is the point that it passes through, the y value of that point. So my y minus y1 is negative 2 equals the slope here of my new perpendicular line is negative 1/3. X minus x1, my x1 is 3. And now all I need to do is to distribute this negative 1/3. This becomes negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 3. Negative times negative is a positive, and 1/3 times 3 is 1. Okay? Over here, these two negatives are going to come together to give me a positive, so I'm left with y plus 2. And so, I'm trying to transform this equation into the slope-intercept form, so I need to get rid of this plus 2 by subtracting 2 on both sides. So I'm left with y equals negative 1/3 x. I have a plus 1 and a negative 2. So this is minus 1. So my equation is y equals negative 1/3 x minus 1. This is the equation of a line that passes through the point 3, negative 2 and is perpendicular to the given line y equals 3x plus 2. Okay, so now that we've gone through these examples, you will go ahead and do your homework. I think it has 13 questions, yes, and everything that you need to know to solve these questions are in our examples that we just covered, okay? All right, have a good time writing equations of lines that are parallel and perpendicular. Okay, so go back to example 1 in order to solve numbers 1, 2, and 3. So first you find the slope of the segment AB, or the line AB, okay? And then you find the slope of the line CD, and you compare them. If they're the exact same numbers, then you know those two segments are parallel. Then you find the slope of EF and compare that to the slope of AB, and that's in number 2. And if the slopes are the exact same, then they are parallel. If the slopes are the negative reciprocal of each other, then they're perpendicular. If they're neither the same nor the negative reciprocal of each other, then they would fall in the neither category. Okay? So keep going back to your examples to solve these problems.